Kia ora again, everyone. Still looking at motion just after we've figured out how sprites work. I want to show you how to get circular motion today. Say you've got a power-up and that causes something to travel in a circle around the character, or say you're in, back in Mario, where they used to have they still do, I guess, if you still play Mario, where they used to have the fire balls that used to travel in a sweeping circular motion. How do we get that? How do we get that in our platformer? How do we get that in 2D space? What do we have to do in order to get circular motion? So I've got a little thing here. This is what we're going to end up with. And as you can see, I've got a main. I've got a main sprite which is just traveling in one big circle, but I've also got another sprite which is traveling in a circle around that circle. If you just pay attention to where that smaller little moon one is, you'll see it's traveling in a perfect circle around that. It's tracing out this really cool spirograph pattern. I really, really like it. We're going to build that today. Great. How? Okay. Let's make a new file. Let's call it circles.py. Let's bring in a little bit of our or should we just write it from scratch? Should we write it from scratch? It's going to be a longer video, but we can do it. Let's import. In fact, we shouldn't even have to deal with sprites, really. Let's import arcade, but we're going to. Don't forget, I'm still in my default directory for my arcade stuff. I'm just sort of putting it all in the same place. So I still have access to coin.png. That's going to be important. We're going to import arcade. We're going to set a width. You guys know how to do this. Speed me up. Jump ahead if you've done this already. And we're going to set a width of 800. We're going to set a height of 800. I do think I should do this from scratch, though, just in case you're joining us for the first time. And we're going to set a title as circles. Capital C. Lovely. We're setting up a class of game, as always, and this inherits from arcade.window. This is all good practice. We need to define, first thing we do whenever we set up a class is we define our init function, and this takes an argument of self, and the first thing we do is we call the super class, call the super, create an instance of the super class, and then call its dot init dot double underscore init double underscore method, and that takes width, height, and title. Cool. Let's. Oh, I didn't use constant case for the title. How annoying. T-I-T-L-E. We got there. Okay, cool. Let's set the background color. Arcade.set background color, and we're going to set it to our old favorite arcade.color.Air Force Blue. Why is that our favorite? It was in the tutorials, it was in the reference, and it looks nice. It's a nice background color. Okay, right, let's get some sprites on the screen. So let's define setup, and that's going to take self. Let's just do one for the moment, and we'll add the second one on afterwards. So let's go self.coin is going to equal arcade.sprite, and it's going to have its image that's associated with it is going to be is coin.png, and I wonder if I can just make everything a little bit bigger for you here. A little bit easier to see, just as we're doing a whole lot of typing. Let's start its center at self.coin.center x is going to be width over 2, and self.coin.center y is going to be height over 2. No, I don't want it in the middle. I want it to rotate around the middle. I want it to spin around the middle, so I want it slightly off center. And I'm going to just move it to the right, maybe by 300. Okay, let's Jamboard it. Let's explain what's going to go on here. Okay. Oop. Jamboard. You can see all of my old Jamboards. Lots of old stuff in there. Okay. So circular motion needs two things. It needs three things. It needs a radius. How far away from this point are we going to rotate around? Of course, that's how circles work. We're going to have a center point. We're going to have a radius, r, and we're also going to have another point that lives there. Okay, where is that point? How do we calculate it? Well, this is actually a really common problem and a serious part, well, not a serious part of mathematics. It's an important part of mathematics that you should understand and that you need to understand in order to get circular motion. This is translating our regular coordinates into polar coordinates. So our Cartesian coordinates on our plane, and here's our plane, Cartesian from René Descartes, the philosopher I think therefore I am, also invented Cartesian coordinates, our x and y. We've got our x and we've got our y. We think of that like that, but instead of x and y, we can think of these points as some angle from, if I draw another point out here, some angle here plus the radius r, and we'll put our radius up there instead so it's not that confusing. Right, okay. How do we convert these? How do we convert x and y into this this polar coordinate? Well, we have some handy mathematical functions already to do all that hard work for us. We just have to know what they are and how to use them. So this is still going to have an x and a y. We're still going to say, I want to point here at this x and this y. But notice this x now, it was here, it's now rotated up to there, according to this angle. This x is now slightly less. But how much? And its y across here and through the r, because I put it in a silly place, is now, and of course, that's our y coordinate over there, and that's our x coordinate down there. Wherever. Our y is now somewhere else as well. Okay. Where are these things? Okay. This x coordinate here is actually going to be whatever this point was. Whatever this point was here, plus the cosine of the angle times by the radius. So here we go. Let's get some text going on. X, and it's going to look a little bit mathematical. Bear with me. X is going to equal the radius times by, and let's make this a bit bigger, the cosine of whatever angle we've rotated by, and y is going to equal the radius times by the sine. And of course, sin, no, it's sine. Sine with an e, but the function misses the e off. Who knows why? Times the sine of that angle. So, as this changes, as this angle changes, we get that lovely, lovely circular motion. And my circles are not that good. So that x is going to change, and the y is going to change. There are some wonderful animations out there that really illustrate this quite well. Ours is going to, but only if you think about what's happening at each particular point. Sine and cosine, you think they're about triangles, they're actually about circles. Okay. Don't forget, of course, with your text, you have to add in your center point. Your center point x plus all of this, plus all of that, right? So whatever this position was to start with, plus the radius times the cosine of that angle, right? And the same thing with the y as well. Okay, we're coders. We're not mathematicians. We have to understand this a little bit, but mostly we just have to implement it, okay? So if that's confusing to you, don't worry about it. Let the understanding come later. Today, just implement it. Get it working, see it working, think about the mathematics of it later on, and hopefully everything will kick into place. Just implement it for now. And then you'll be familiar enough with it so that when you see it later, you'll go, ah, right, okay, wonderful. Just as long as you remember, x, oh, my arm is disappearing. X is going to be the radius times the cosine of the angle. Y is the radius times the sine of the angle. Cosine for x, sine for y. Let's do it. Okay, we've got a coin. We've got it at a initial position. So the initial position is currently our center point, which is the middle of the screen. Center point is the middle of the screen. Width divided by 2, height divided by 2, and plus 300. That's our radius is going to be 300. Let's actually make that. No, we'll deal with that in a moment. Okay, but our y is. There's currently no change in the y, right? If I put plus 0 there, redundant, yes. Useful, maybe. Does it help you understand? I hope so. Okay. Right. Define, update. What's going to happen, and again, get rid of the gunk that IntelliSense gives you. What's going to happen every frame? Well, first of all, we need an angle. And that angle is going to change over time as it animates. So let's start that now. So self.angle is going to equal nothing. So every frame, what I want you to do is set self.coin.center x to our center point, width over 2, plus the cosine, plus the radius. What's our radius? Let's make a little thing called self.radius. And we're going to set that equal to 300. It's going to be self.radius times by the cosine of self.angle. I really wish those self dots weren't there complicating things, but they are. We live with them. We're coders, right? Okay, take that same thing, copy it. center y, of course, is height divided by 2 plus the radius times the sine of self.angle. Okay, there's a bit of a problem with these 2 lines of code so far, and that is cos is not defined. Python does not have sine and cosine baked into it. It is, however, part of the mathematics, the math default library. So import from math import cos sin. There we go. And those, you can see down here, those little warnings disappeared. Okay. That is going to change the position of our circle. Or no, it's going to set the position of our circle. It's not going to change it until we change the angle. So each frame, let's change self.angle by not 1. Whoa, that's heaps. Let's change it by 0.1. Okay. Let's run that. Why am I running it? We know it's not going to work because we've missed something very important. You know what we've missed. Hopefully you don't make the same mistake. There it goes. Not really anything happening. Kill it. Let's try again. This time we need to... We've missed lots. We've missed lots of stuff. Getting a bit too ambitious. Define on draw. Define on draw, of course. What needs to happen on draw? We need to arcade dot start render. Arcade dot start render, and we need to say self dot coin dot draw. And now we need to say game is going to equal a game, and game.setup arcade.run. Let's try that. Here we go. It's thinking about it. Maybe jump ahead. Hopefully it boots up. There goes. Just goes to show that you don't need the best computer to be a great Python programmer. You just need to let it run sometimes. It's wonderful. Hey, there it goes. Hey, excellent. Circular motion. Look at this. It is zooming, absolutely zooming around there. The coin is still massive, but there we go. We've got circular motion. What do I need to do if I wanted to change direction? What you need to do, of course, is you need to just turn the angle into a negative number, and it's going to spin the other way. There you go. Cool. Can we make that a little bit smaller? Let's slow it down. Let's slow it down by a lot. Let's turn it back into a positive number. Okay. That's cool and all. How do I get something, how do I get it like a little moon of itself, of its own, right? It's this wonderful planet orbiting, rotating around a screen. How do we get it a moon of itself? Well, all we need to do is we need to think about what the center point is, and we need to think about giving a moon its own little angle and its own little radius and its own change of angle as well, and it will spin around the current coin which is spinning around as well. Let's do it. Okay, so we need Let's create something. Let's call it a moon, because I think that's the best analogy, right? We've got a planet going around. There's going to be a moon going around that. Give yourself a challenge. See if you can pause the video now and find out how to do this yourself. And pause. If you get it right, awesome. Come back here and check. If you struggle and you can't manage to do it, then once you've given it 10 minutes and you start, come back here and we'll do it together. Do that now. Awesome. You're back. Well done. Let's go. Self dot moon angle is going to equal 1, just to get it off, so they're not starting in line. Don't want them to start in line. Self dot moon angle is going to be 1. Self dot moon radius is going to equal 50. Does that sound good? Of course. Okay. So, after all of this, we're going to say self.moon is going to equal arcade.sprite. And it's going to, its image is going to be coin.png. Whoa, 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 whoa. Can't see anything. It's also going to be about 0.3 big. And I'm going to drop the size of my initial planet one to about 0.5. Okay, cool. Where, oh where, is my moon going to go? What's its center X going to be? Well, its center X is going to be, it's going to be the center X of the regular coin plus some stuff, right? And that stuff is that sine, cosine stuff we were talking about before, plus the radius and all of that extra goodness in there. So self dot moon dot center X is going to equal, try that for a third time, self dot coin dot center X plus self dot radius, moon radius, times the cosine of self dot moon angle. Take that whole thing, put it there as well. Self.moon center y is going to equal self.coin.center y plus the sine of the moon angle. Oh, great. We also need to put this in our update function. So take that whole thing, copy it, put it in our update function. And now let's also say self dot moon angle plus equals a little bit faster than our coin is rotating. Let's put it spinning at 0. Oh, well, that's going to be way too quick. 0.1113. Okay, something a little bit odd. I don't want them to line up perfectly. I do want them to be a little bit out of sync, just so you get some cool patterns happening. So I'm just going to make it a little bit of a different function, different decimal. Yeah, let's see if that works. It's not going to work. Why is it not going to work? Can you tell how it's not going to work? We're not drawing it. Self dot. Oh, and it's booting up. Yeah, cool. Still got a coin on, and we don't have another one. We're not drawing it. Self dot moon dot draw. Huzzah! Yeah, cool. Look at that. we've now got circular motion on top of circular motion. And you could make more of those. You could do, you could make a class that was a little satellite or an orbiter and they all stacked on top of each other, or that there were multiple moons for one planet, or maybe this is a sun which is also spinning through a galaxy. Maybe your job was to go through an orbiting galaxy and collect some things, collect some space rocks or some space gems, or a recovery mission in where there was some sort of spinning, orbiting thing, or maybe you just wanted the Mario, the Mario wall of fireballs that were all rotating together. How would you do that? Well, you would have the same angle, just each thing would have a slightly different radius, and they'd all travel together in the same circle. Cool. Also, a little bit of fun, not that useful for making games, but if you just get rid of the arcade.startRender, you get this really, really cool effect where the background's not drawn in each frame, so you get some cool trails, and I think it looks nice. And you can sit and play with some spirograph patterns all day if you would like. There we go. Maybe a separate sprite, or maybe even you don't want to use sprites and just want to draw circles. There you go. Circular motion. Excellent. Something a little bit even more difficult than this. Next video, I'm going to show you how to make a homing, how to make one sprite follow another sprite or track it, how to home, maybe a homing missile, maybe a zombie that's chasing you, or something like that. Requires a little bit of trig as well, just like this did. Excellent. Have fun with this, and I will see you in the next video.